Hi, this is Jeff Carpenter from DataStax, and I'd like to talk to you about why Kubernetes is the best technology for running a cloud-native database. Or maybe another way to put it, if you want to tell me that your database is cloud-native, you're going to have to show me how it runs on Kubernetes. Now, whether or not you think this is a controversial statement, my goal here is to convince you that there are design principles at the core of Kubernetes that we really have to consider and leverage to make sure our data infrastructure is truly cloud native. Now, you might say to me, hold on, it seems like we're not so far removed from the days in which we were all told Kubernetes was not yet ready for running stateful workloads in production. And you're right, and I'm sure all of us have heard that statement, and maybe most of us were the ones that were saying it at different times. My colleague Chris Bradford was one of those people. And Chris had a great article on the News Stack earlier this year. He traced out his journey from being highly skeptical of running databases in containers and using container orchestrators like Kubernetes. And now he's an enthusiastic supporter of the idea. And he's a key contributor to a project that's an open source project called Cassandra. It provides an operator for running Apache Cassandra on Kubernetes. Chris is actually giving a talk on Thursday afternoon that you should check out about multi-cluster database deployments. All right, so let's dive into these principles. I've got 5 of them. I'm not going to tell you up front what they all are, but let's see what we can learn from all the years of design experience that have been poured into Kubernetes. So the first thing we'll look at is how Kubernetes treats these basic blocks of cloud infrastructure as compute, network, and storage, and puts commodity APIs around them. The major cloud providers started us down this road with the way that they packaged up their services. You can think of AWS S3 or the Google Compute Engine, but Kubernetes has taken this to a vendor-neutral place. It allows vendors to innovate and compete, and it allows users to select the solutions that work the best for them without being afraid of lock-in. So, how about some examples of what I mean? Let's look at the Kubernetes API, and first we'll talk about compute. Now, Kubernetes gives us resources to run applications like worker nodes. Those can run our pods. We can deploy more complex applications that need scalability and availability, and for that we have constructs like deployments, stateful sets, daemon sets, and so on. Let's talk about networking. Kubernetes gives us multiple flavors of services, including the services just inside our Kubernetes cluster, or the ones that we want to expose more broadly using load balancers, or we can even manage more complex behaviors and combinations of services using ingress. And finally, storage. For storage, Kubernetes gives us a whole persistent volume subsystem that allows us to decouple our application storage needs from the actual storage volumes that get assigned. And we do that through persistent volume claims and storage classes. And these primitives are exactly the ones that we use when we deploy databases and other stateful workloads on Kubernetes. And the thing is, they also set an example for us that we need to follow when we build data management capabilities ourselves. So we want to work towards the same kind of standard APIs and the same quality of standardization of these APIs that we see in Kubernetes itself. The second principle that Kubernetes gives us is to separate the control and data planes. Now, in my experience, the control plane side of most data infrastructure, it hasn't received nearly the same amount of love as the data access interfaces. And the results of this really show. So databases are often difficult to manage. They have antiquated interfaces with too many configuration options. And I know this firsthand from my background with Apache Cassandra. And it has a pretty old school management interface that's based on Java management extensions, which has had a lot of security issues over the years, and et cetera. And Cassandra also has a YAML file that's several pages long with different configuration options that you can tune. So treating the control plane as a first-class citizen is a really important part of delivering cloud-native data infrastructure. Now, there was an article from this spring, again by Bassam Tabara, which really resonated with me. And in this article, he argues that the real superpower of Kubernetes is its control plane, because it relies on a simple control loop pattern that's both powerful and easily extensible. So he cites the Crossplane project as an example of an attempt to build a universal control plane leveraging Kubernetes. Closer to home for us in the data management world, we will be familiar with the Container Storage Interface, or CSI project. Now, this is not exclusively tied to Kubernetes, but CSI does a great job of defining distinct data plane and control plane interfaces. And this is why all the CSI vendors that I've seen, they have a Kubernetes offering. It's a no-brainer. CSI implementations on Kubernetes build on these same primitives that we discussed before: compute, network, storage. And this plugs really nicely into the persistent volume subsystem of Kubernetes to link the application pods with the storage that they need, without a lot of mental overload for those of us who are deploying applications. Now, the next principle follows from the last one. Kubernetes shows us that observability is super important, and it strives to make it easy to understand what is happening with our applications and the pods that they're composed of. This starts with basic building blocks like providing access to the container logs inside our pods and using liveness and readiness probes as it helps to control pods. Now, there's also a rapidly maturing ecosystem of technology for the other observability pillars like metrics and tracing. Now, this diagram is from the Cassandra project I mentioned earlier for running Apache Cassandra on Kubernetes. Now, it was super easy to build metrics collection into Cassandra just by including the Kubernetes stack using a Helm chart. And then we configured the Prometheus service monitor with information about how to connect to the Cassandra nodes, what service to use, and what metrics to collect. Cassandra also includes an adapter that wraps the legacy JMX interface that Cassandra exposes in order to provide a more friendly face to Prometheus for the metrics collection. And this shows that you don't always have to rewrite entire applications to make them run well in Kubernetes. Sometimes you can wrap and adapt them, and that's okay. The next thing that we can learn from Kubernetes is that the default configuration is secure. Now, for too long, we in the software development community treated security as an afterthought. We delivered features, more features in order to meet the demands of our business managers and our customers. And then we'd kind of go back and add security later when things started going wrong. And Kubernetes forces us to adopt the opposite approach. We have to think about security up front. Just for some simple examples of this, ports are closed by default in Kubernetes. You're not getting anything through to any port on any of your pods unless you open the port. So that's something that we get for free just by using Kubernetes. But the other part of securing databases is something that we have to work a little bit harder for, and that starts with authentication and authorization. And thankfully, we have other Kubernetes security primitives like secrets that we can use to manage database administrator and user credentials. So you see that Kubernetes gives us the tools to make things secure, and we need to make sure that we use them. The fifth and final principle is to prefer declarative configuration. Now, Kubernetes is famous for pushing us toward declarative APIs over imperative actions. How many of us have killed a pod only to see it get recreated because we forgot it was wrapped in a deployment? And then Kubernetes does its job of maintaining the number of replicas we asked for declaratively and recovering from our misjudged imperative command by recreating the pod. Now, for those of us in the data management world, this might be the hardest principle to adopt because we're so used to getting into the details and twiddling with low-level configuration details, tuning parameters of our databases, all of the classic DBA skill set, right? Kubernetes sets an example for us here. It sets some boundaries. We tell it what we want the world to look like, and Kubernetes figures out how to do it. All right, but how is this going to work? Because we know that databases and stateful workloads can be pretty complicated. Well, this is where we return to the superpower of the Kubernetes control plane. We can extend the control plane by writing our own operators and controllers and custom resources that automate the lower level details of managing our favorite data infrastructure. And the more mature our data infrastructure is, the less complicated our operators will be. So there is some incentive for a little bit of refactoring here perhaps as well. So just to summarize, here's the design principles that we can learn from Kubernetes that we should really be applying to our databases, data infrastructure, stateful workloads on Kubernetes. Leverage compute, network, and storage as commodity APIs. Separate the control and data planes. Make observability easy. Make the default configuration secure. And prefer declarative configuration, again, by providing operators and controllers or by using them. All right, well, here is a bonus principle that I would like to present to you. It's non-technical, of course. It's that we draw on the wisdom of the community. Now, over the years, I've worked in a lot of systems in both closed and open source applications. And in my experience, the best designs are the ones that are developed and shared in the open so that they can be borrowed and refined by others. And then the cycle continues. I'm really appreciative of groups like the Cloud Native Data Management Day, the Data on Kubernetes community. These are communities that are working really hard to push the state of the art forward for storage and data infrastructure on Kubernetes. I see these communities as dreaming up many of the features that are going to work their way into getting implemented and making feature improvements on Kubernetes itself, as well as related projects like Cassandra, which again builds on top of Kubernetes to deploy Apache Cassandra. So because of this continued innovation, there's a lot more to be said than I could possibly cover here in this short talk. So I decided to write a book. I'm working on an O'Reilly book with Patrick McFadden called Managing Cloud Native Data on Kubernetes. And we are trying to cover as much of the spectrum as we can of data and data intensive applications on Kubernetes. We're starting from basic principles and working our way all the way up to next generation capabilities like data services, data meshes, containerized data, declarative data, and whatever ideas you want to feed to me about what we think the state of the art is and what's coming next. So the first 3 chapters have just gone live in early release on the O'Reilly Learning site. And of course, more are on the way. And so if you want to see the outline of what's coming, you can check out the outline that's openly available on GitHub. And that's also where the code samples for the book are located. I'm also giving a talk on Thursday afternoon called, actually right before lunch on Thursday, called How to Put a Database in Kubernetes. So you should come check that out if you're interested. And of course, we have a booth. DataStax has a booth. If you're in person and want to come hang out, there's also a virtual booth. So this talk that I'm giving on Thursday is a beginner level talk. So we'll start with persistent volumes, and then we'll build our way up to using stateful sets to deploy databases. It should be a lot of fun. And even if you're an expert that's been around for a while, if you have some colleagues that are maybe coming up to speed, this might be a good jumping off point for them. And that's all I have to share today. Thank you very much for your time, and I hope that you really enjoy the rest of Cloud Native Data Management Day and the rest of KubeCon. See you soon.